Okay, this is Organic Reactions Part 1. Once again, one of those videos where I would say take close notes on what's going on, take very careful notes, and then try to review this video a couple of times to get the hang of things. You will know when you're going to do what's called an addition reaction when you've got a double bond within the carbon chain. So the double bond has to be between carbons. Now, these organic reactions, what's going to happen is you're going to learn the 5, and then what you're going to do is you're going to use them later. What do we add to these carbon chains with the double bonds in them? We can add hydrogen plus any group 7 element, so we'll call those X. So for example, HCl, HBr, HI. We can add water, which we'll call HOH, and I'll show you why in a minute. HNO3, that's one we actually do in class, so we make something fun with that. And NHH, NH2. Now, the other thing you can do is you can add an X2, like 2 Cls, such as that. So the X is anything in group 7. FCl, BRI. So let's say that we add HOH onto here. We've got 2 products that can form. Let's take a close look at this molecule. Every carbon has 4 bonds. 1, 2, 3, 4. So if you put your pen on one of the C's, 1, 2, 3, 4. 1, 2, 3, 4. And what you do when you add on to a carbon chain with a double bond in it is you break that double bond. So you can make one of 2 things. So this last carbon stays the same. It's got 3 bonds coming off of it. But now what you've done is you've added an extra bond on here. So let's say if we added HOH in, which is water, the H could go here and the OH could go there. So one portion of this molecule goes to one carbon on the double bond and one to the other. So whatever gets added has to be added in where the double bond was. So let's do the opposite now. All we're doing is adding the OH to the other carbon and the H to this carbon. So you know when you're going to have an addition reaction because you'll have a double bond in a carbon chain. And then you add the materials in. Okay, let's take a look at an elimination. And an elimination is the opposite of this. So we have a carbon chain and we have a single bonded functional group in there, such as OH. If we add heat, which is usually in the form of H2SO4 in chemistry, so if we add sulfuric acid in, and we do this in one of our labs, we will strip off the OH. But when we strip off an OH, we also must strip off an H. So I could have taken this H, I could have taken this H. I can't take an H off the carbon that I'm taking the OH from. So I have to either take an H from here or an H from here. Let's say I take this one off. What do we get? So I remove that OH, it's no longer there. I remove that H, it's no longer there, and we make a double bond. I hope if you study this, you can see the addition is the opposite to an elimination. In a substitution, what you're doing is you're switching out one single bonded functional group for another. So what's going to happen here is the OH and the Cl are going to switch places. What we care about in organic chemistry is this molecule here. We don't care about the HCl. I haven't added all the hydrogens in, but there they are if you need to see them. So in an addition, we start with a double bond in a carbon chain. In an elimination, we make a double bond in a carbon chain. And in a substitution, we just switch places between 2 functional groups.